In this video, we will check for queries that is going to give us perfect estimate, lower and higher estimate. I'm going to use database AdventureWorks DW. So what I'm going to do is I'm going to insert close to 78 rows with values that is mentioned here on table 1, and then another 10 rows with values mentioned here on table 1. If I look at the table structure, it has got four columns. Column 1 being the primary key, which has got cluster index as a result and is on column 1, and it is having an identity column with seed and increment 1. Column 2 is varchar, column 3 is integer, and column 4 is a date time. We have a non-cluster index ix underscore test located on column 2. So let's insert the required rows for this demo. I have inserted the required row. So what I'm going to do is just to rule out any stats issue, I'm going to update table 1 with full scan. It is completed. So now what I'm going to do is I'm going to enable the actual execution plan, and then I'm going to execute these 3 queries. So what I'm basically doing is I'm trying to return all the rows from table 1 where the predicate column 4 is having this particular value. That is, one is 10 January 2024. 9:31 p.m. 4 seconds. The second one is 10 January 2024, 9:30 p.m. 04 seconds, and third query is again 10 January 2024, where the time is 9:29 p.m. 04 seconds. So what we'll do now is let's enable the execution plan and execute this particular query. So what I'm able to see is the first query returned 500 rows, second query basically returned a value of 78, and third query basically returned close to 10 rows. Now let's go to the execution plan. What we'll do is we will check the execution plan for each and every query. The first query, if we look at the cluster index scan, what I'm able to see is we are estimating 500 rows, and then we are returning close to 500 rows. So it is a perfect estimate. So we are estimating 500 rows, and then we are returning 500 rows. The first query seems to be having a perfect estimate. Now on the second query, what I'm seeing is we are estimating close to 49.6 rows. But we are ending up returning close to 78 rows. So here what I'm seeing is we have a lower estimate. We are estimating fewer rows, but we are returning more rows. So this particular query seems to be having an issue wherein there is a lower estimate. So the third query, if we look at it here, what I'm basically seeing is we are again estimating 49.6 rows, but we are ending up returning close to 10 rows. If you see here, the estimated number of rows per execution is 49.66, but the actual number of rows for all execution is close to 10. So here it is an higher estimate where we are estimating a higher number of rows, but we end up returning very less rows. Yep. So now what I'll do is I will check the statistics for column 4. So we will pick up this statistics which is on column 4, and then we will check the histogram to see where did we get the estimate values for each of these queries. So what I'll do is since it is 2024, what we'll do is the first query is on 21/31/04. So if you look at it here, what we are able to see is there is a direct hit as far as the histogram is concerned for the first query, wherein it is 10 January 2024, 9:31 p.m. 4 seconds and 4:33. So we have a direct hit on the histogram steps. So we will be using the EQ underscore row. So in this case, it will be 500. So what we'll do is we will look at the next one, which is basically 10 January 2024, 1:30 the 9:30 p.m. 04 seconds. In this case, we don't have a direct hit, and this particular predicate that we are talking is basically buried between 196th and 197th step between these two. So in this case, what we are going to do is like we are going to utilize the average range rows, which would be 49.6667. And the next query predicate is also like buried between these two things because it is 10 January 2024, 9:29 p.m. 04 again. So it is again buried between this 196 and 197 steps. So we will be utilizing this average range rows, which is again 49.667. So what we'll do now, we will execute this query one more time, and then let's see if the estimates that we have noted down is right. Okay, so the first query, the cluster index scan, did a estimate of 500, which is same as what we have noted. The second and third query, both are doing an estimate of 49.667. So we clearly understand from where we got this value. For the first query, we pick it up from the EQ rows because we have a direct hit on the histogram. But the other two queries, the predicate is buried between the histogram steps. So we had to use the average range rows, which is 49.667. Again, the first query has a perfect estimate wherein we estimate 500 rows and then return 500 rows. The second query, there is a lower estimate wherein we estimate 49.6, but we end up returning more rows, which is 78. Third query, we estimate 49.6, but we end up returning 10 rows. So it's a higher estimate wherein we estimate more rows, but we end up returning fewer rows. That's it for this video. Thanks for watching. Have a great day. Jai Hind.